Hello, in this video we're going to make the Cowcatcher. You can see there's already one made here, but I didn't really care for how that whole video turned out and the explanation, and I really wanted to find out how to do one thing in the program that I wasn't aware of until I looked a little deeper into it, and that is, how to explain this, to take some geometry from one sketch and then project it onto another sketch plane. Kind of like the sketch version of lofting. Sometimes you want to use geometry that's somewhere in the background and like trace it onto your new sketch plane. So I just looked it up on YouTube and now I'm fitting to do just that. So I'm going to make the Cowcatcher, and it starts off by making kind of a home plate shape. If you're into baseball, I'm going to get it in the zone for how much it should be. It's 1.8 inches wide, and well, that's a pretty bad drawing. But I think once we dimension this up, turn on D for dimension, and assign all these dimensions, should turn out okay. Let's do 1/4 of an inch over here. And this one really needs to be perpendicular, so let's go ahead and add what's called a geometric constraint, a perpendicular constraint. Looks like a T on its side. You click the bottom line, you click the vertical line, and now you do in fact have a 90-degree angle here, and you can see the perpendicular sign right there. So once it's going vertical, it's really easy to dimension. So throw that dimension in here, and then the linear dimension, not the aligned dimension, but the linear dimension between that peak and the edge is 1.8 divided by 2. That'll center it, make it all nice. Oh, one more dimension to go. From here to here is some value as well. It is 1 inch on the dot. So put in 1 inch, we get that nice home plate shape. Finish the sketch, and now the next step is to throw a plane out here, the height of the Cowcatcher. So you open construct and hit offset plane. I want to drag this, and the height of the Cowcatcher, when you look at it, in the top left diagram on page 8, it's 0.75. And so that puts a plane 0.75 away from the existing sketch plane. And once that plane is there, we can put a sketch on it, right? Now, this is the point where I want to basically use this geometry to make sure that my two profiles are exactly aligned with each other. And I wasn't able to, I think in the very first video I made, I just lucked out and got the lines to hook up. But there's a way to do it so it works every time. So what I'm going to do is kind of show you where to look. You open up Create, and then there's this thing called Project Include. Okay? And Project, if I click Project or P, I can click these lines. And now, okay, when we go ahead and look at it from an angle, we've got two of the very same sketches. Okay? And these I'm just going to use for reference geometry, so since that's the case, I'm going to change them to construction lines if that's possible. So let's highlight all of them and construction, normal construction. So now they're construction lines. And the clue to you is that they are dashed lines. So they're not going to really affect our design too much. But learning how to do those things, how to project geometry and how to change geometry into construction geometry, those are pretty powerful tools to help you with your designing and keeping it smooth. So now I'm going to draw, and I'm purposefully drawing it kind of bad, my second home plate shape. 1, 2, 3, 4, 5 side. It's a pentagon. Who knew? And I'm going to throw some dimensions on there. So this, oh wow, that one came out just right. That is supposed to be 1.2 inches, so that's a good one. These ones are the same as the bottom, so those are both 1/4 of an inch. I think I'm going to center this one first before I do the other dimension. So 1.2 divided by 2. Oh, what just happened there? My goodness. Let's undo that a couple times and maybe try to help it out a little bit. Let's delete this. Kind of drag this right where we need it to go. Just kind of manipulate the endpoints there. I'm gonna put a perpendicular constraint. Oh, okay. escape. Put a perpendicular constraint between these two to get it to stand upright. Go ahead and dimension this one, 0.25. The distance from here to here on the top one is 3/4 of an inch, 0.75. And then I think if we do this one again, maybe it'll cooperate, 0.6 or 1.2 divided by 2. Okay, great. So we're all good on this. Now we want to bring this line up so it's right on here. And if I was just to grab it, I could put it and try to get it close and try to get it close and try to get it close. But you'll never know if you're really there. What you can do, this is the whole reason why I projected this geometry, is to hit the coincident constraint. Constrains the position of 2 points or a point and a line curved together. You could also use collinear. Maybe that's a better one to use, just because that's what it's intended to do. So we click that line, and they become the same line. So we're feeling strong. We're going to finish the sketch. The next move is to loft these two profiles together. So under Create, you have Loft. Let's go ahead and click that one and that one. Say OK, and it makes us that nice Cowcatcher solid body. The next step, is to shell the body, and the shell, I believe, is 0.1 inches. And you can find that on the top right diagram. 0.1 inches. We're going to throw in the little, decorative part. That makes it look even more Cowcatchery. So let's put a sketch on this. And we'll use offset. And we'll click this shape and just bring it in negative. Let me take a look here. That is, which diagram is that on? Oh, it's on the top left diagram. It's negative 0.1. So when you get done, it should look just like that. Say OK. Let's go ahead and finish the sketch and extrude cut it. You could do it in 2 sketches, but for this video, I'm going to try to do it all in. I'm going to try to use a patterning tool called Mirror. No, that's a little far. I think we want 0.5. So to mirror this over to here, and I think what I'm going to need to do that is insert a mid-plane. So I want to put a mid-plane in between 2 planes. Well, that's not gonna do it. Let's try to construct an offset plane. And let's look at our origin planes over here. Let's just zoom out. I think this is the one we want. And if we look at it straight on here, we just want to pull this right to there. Is that on there? No, and it's a little angled. That's very odd. That is very odd. Okay. Well, we never give up. Let's just do it the easy-ish way. We're going to go ahead and put a sketch on here. Zoinks. I'm going to use the offset tool and grab this. We're going to bring it in negative 0.1 to get that nice outline. Finish it and finish that and extrude cut it in 5/100ths of an inch. So we'll go negative 0.05. So now we've got the 2 decorative portions on there. Let's put a sketch on the back. We're going to locate 3 cylinders. Let's draw them in their general spots at their relative sizes. Let's go ahead and turn on dimension. Each one of these cylinders is 1/8 of an inch. So let's go ahead and do that. Up in the geometric constraints, you can click equal and make them equal to each other. That's a quick way to do those kind of things. Let's go ahead and locate the 3 cylinders. From the bottom, it is, guess what, 1/8 of an inch. So that'll slide it down. Both of these are 1/8 of an inch, 0.125, bam. This one up here from the bottom is how far? Well, I'm looking at that middle left diagram. It's 5/8 of an inch, or 0.625. That should move it where it's supposed to go. Now, let's locate them laterally. This one should be centered, so it's 1.8 divided by 2. Okay, that slides that over from here to the edge. Let's see if I can find that value. 0.275 is what I'm reading on the top or the middle right diagram. 0.275. And then, strangely enough, it gives us a dimension from there to there, and that's 1 1/4, 1.25. And I believe we are all located. We've located to 2 different sides. We're going to extrude all these. They pop out the back a distance of 1/8 of an inch, probably. That's what I'm assuming, 0.125. And then we have to put a little chamfer around the edge, and the note for the chamfer is in the top right diagram. It's 45-degree chamfer, so that lets you know it's an equal distance chamfer right here. And so all you need to do is put in the value. You can put it up here, you can put it down here. I'll put it down here. It's 0.01, 1/100th of an inch to just give it that little teeny chamfer on the edge. Okay, so that's how you make the Cowcatcher, and especially finding those things about projecting one bit of geometry onto another. We failed trying to insert a midplane. Perhaps if there was a plane here and a plane there, or we didn't have that angle going down the side here, it would have been a little bit easier. But even when we used the origin plane, it was like tilted, which is kind of mysterious. But here you have your Cowcatcher, and reading some of these notes was really kind of difficult, and it should maybe, if you're looking at the page with all the dimensions on it, kind of get a feeling for why we like to dimension on orthographic views rather than isometric views. It can become really kind of all chaotic when extension lines are crossing over each other, and yeah. Okay. Thank you.